Thank you very much for attending this session. Today I talk about very basic tools for forecasting in LittleField Technology games. Here is the game interface. We can go to customer orders, click on it. When we click, this menu comes up. Job arrivals are those which have come to your system and you have accepted. Rejected jobs are those jobs, those contracts which have come to your system, but because you have fixed your maximum working process to something, they have not been allowed to come in. You have rejected them and they are gone and they will not come back. We need to download them. If you click over there, there is an arrow. By using that arrow, you download them. Here I have downloaded Game 1 data and Game 2 data. When you are considering capacity planning, increasing the capacity, buying more machines, you need to consider both the rejected job and jobs arrived because you are planning for the whole thing. But if you have already decided about the capacity of your stations and you are doing, for example, inventory control, then you just need to work with arrival jobs because rejected jobs do not exist in your system. In this very basic session, I will talk about stationary demand. What is stationary demand? Stationary demand is a demand like this, which I cannot see any pattern, upward pattern, downward pattern, or any periodic up and downs. Demand in Game 2 is entirely stationary. In Game 1, at the beginning, maybe the first 70 days, you do not have stationary demand. Demand is going up. In the last, say, 50 days, you do not have stationary demand. Demand is going down. But between these two periods, about 130 days, you have stationary demand. This graph shows us the demand for Game 1. As you see here, all these data are below and then they go up. Therefore, there is a trend like this in this data. This is non-stationary. This is stationary. Game 2 is entirely stationary. Game 1, not in the first 70 days, not in the last 70 days, but for the rest of the game, it is stationary. One way of recognizing stationary demand is looking at it and see if we observe any systematic pattern like trend up, trend down, cyclic movement. If you see a systematic pattern here, not stationary. Here, stationary. One other way of differentiating stationary and non-stationary demand is to add the demand up. This is day 1, this is day 1 and 2, 1, 2, and 3, and here this 33 is summation of all demands from day 1 to day 70. This is for Game 1, this is for Game 2. Here is for Game 2. If we draw that cumulative curve, it is very close to a straight line, as we see here. This is for stationary, and it's Game 2. But when we draw it for Game 1, we see that the curve is somehow away from a straight line, and that is non-stationary. And these lines that I have drawn here or here, they show the average for each game. To estimate the demand for the entire Game 2, which the demand is always stationary, and for the middle part of Gate 1, for example, from say 130 days from day 70 to day 200 or something like that, when the demand is stationary. We can use just average, standard deviation, descriptive statistics. We can feed normal distribution and Poisson distribution to the experimental data, to what we have observed in the game. We can use moving average, and we can use exponential smoothing. For the periods when the demand has upward or downward trend, we need to use techniques such as regression or trend adjusted exponential smoothing, which is also called double exponential smoothing. I will explain all of them and we will implement them in the game. Let me copy this page. We said we go ahead and look at the job arrival, and also we look at rejected jobs and add them together. These rejected jobs were rejected. They didn't come, but if you are doing capacity planning, we need to consider them. Job arrival, rejected job, we add them together. Equal to average. And I lock it because I want to then copy it down. Standard deviation of the sample. We have sample, we don't have population. Mean, max, count. We know it's 50, but still count it. Confidence interval equal to confidence normal. Alpha, we want to know with 95% confidence that at what level would be our demand. Alpha is 1 minus confidence level, so that is 0.05. Standard deviation, it is here. And count, it is here. Enter. Equal to average minus 95% margin equal to average plus 95% margin. Therefore, the average demand is 15.5, standard deviation 4. You may also include coefficient of variations, which is equal to standard deviation divided by average. So we have enough knowledge about this demand. We know that with 95% confidence, it would be between, say, 14.36 and 16, or between 14 and 17, with even much more. We may just stay here. This is our understanding of demand, and we may do capacity planning accordingly. But we may also exercise a little bit more, not for the purpose of the game, but just to have more knowledge about things that we can do in these situations. Let me prepare a histogram equal to minimum equal to this one plus 1, and then I come down until I reach 26. Now I type equal to count if. Count if, the range that I'm looking at is my demand, and I lock it because I'm going to copy it down, comma, and 7, go to 9, 8, 7, enter, and that is my histogram. And if I divide each one by count and lock it, I will get the percentages. And this is my distribution. I want to know how close it is to normal distribution and Poisson distribution. Equal to norm distribution, x, 7, average, standard deviation, and I lock these two because I'm going to copy it down. And then I want to draw the curve, so I don't put 1, but 0. It will draw the curve for me. Click. Now I have fit a normal distribution to this curve. For Poisson, equal to Poisson distribution, x, comma, average, here. And in Poisson distribution, average and standard deviation are equal, so I don't need to enter a standard deviation. And then, because I want to draw the curve, I enter 0 as my last argument. And I also need to lock this average because I'm going to copy it down and then click. Now I have good information about everything in the stationary demand for my manufacturing or service system. Let me just quickly show you how I did this graph. Go here, historical data, insert, chart, I insert this. Then I come here, select data, edit horizontal, and then I go and mark this column. Therefore, 1, 2, 3, 4 was changed to 7, 8, 9. Undo, 1, 2, 3, 4, and this is redo, which is 7. Then again, click on this, Control 1 here, change this color to, say, this one, and then you go here and change this gap, say, to 30%. I can go here, copy, click, paste, copy, paste, change series type. For this one, use this graph, and for this one also I say use this graph. Okay, now that is very similar to what I have, and of course I can go here and change color. Thank you very much for attending this session. We gained some basic understanding of the demand in game 2 and the middle of the game 1. As I said, beside descriptive statistics that we applied here and fitting normal and Poisson distribution and seeing the historical data, and visualization is really one of those things that we really like to do in this class. Now we have basic knowledge. We can then implement moving average, exponential smoothing on stationary data. For non-stationary data, at the beginning of game 1 and at the end of the game 1, which we have upward and downward trends, we can use linear regression and trend adjusted exponential smoothing, which is also known as double exponential smoothing. Thank you very much for attending this session. We will have more talk on LittleField Technologies.